So in this video we are going to discuss about problems on sequential circuits. So here they have given a of t plus 1 is equal to ax plus bx, and b of t plus 1 is equal to a bar x, and y is equal to a plus b into x. Okay, so here they are given this two are your next state value, and this is your output. Okay, so on seeing that they have given they have used two D flip-flops. Okay, two D flip-flops, one is A and B, one is A and another one is B. So design they are asked to design a sequential circuits. Okay, synchronous sequential circuit. So this is of two type. One is Mealy and Moore. Okay, so you can see here the output y depends on a comma b and x, right? So what is a and b? A and b is your present state, and x is your input. Okay, so hence the output depends on the present state and input. This has to be a Mealy synchronous sequential circuit. Okay, okay, so let me so what is the question is they have asked to draw the logic diagram of the circuit, and second one is derive the state table, and last one is derive the state diagram. So let me change the question, right? QA plus is nothing but a of t plus 1. Okay, that is equal to ax is nothing but qa of x plus qb of x. Okay, this is what they have given. Next qb plus is nothing but b of t plus 1, right? And your next state, that is equal to qa bar x. Okay, what is y? Y is nothing but qa plus qb into x. Okay, so this is what question. Okay, I have changed the a of t plus 1 to qa plus and a to qa. Okay, so they have asked to implement that one in a D flip-flop. So we must write the excitation table for D flip-flop. So q plus is equal q plus is your input, is your present state and the next state, and D is your output here in this table. Okay, so the what is the next state values, you will get it at the output of the, you will get it in the D. So I can write D is equal to q plus. Okay, so I can write this one as instead of qa plus I can write it as dA, and qb plus I can write it as dB. Okay, so now I can draw the flip-flop. Okay, so now I can draw the logic diagram. So first let me draw the Let me so this is your D Q bar, and this is your clock. Since it is a synchronous circuit, the clock is common. Okay, and this is your A and this is your B. Okay, so what is DA? DA is nothing but QA 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 X and X into QB, right? This has to be added to the OR gate and it is given to D. Similarly, this is QA bar X that is given to DB. What is Y? Y is nothing but for Y you don't need this one. So what is Y? Y is QA QB. So this is your QB and this is your QA. Okay, QA and gate, this is your Y. Okay, this is your logic diagram. So first I have completed. Next I need to draw I have to determine the state table. So in order to determine the state table, let me write the transition table. Okay, so what are the present state I am having? One is QA and QB, right? So the values are 0 0 0 1 1 0 1 1. So how many inputs I am having? Input is x. So the x value should be either 0 or it is 1. So for this one, what is my next state? Okay, what is my next state? So this is QA plus and this is QB plus and this is QA plus and QB plus for that one. And also I need to find the value of output, right? So output is for x is equal to 0 and x is equal to 1. What is the value of y? Okay, so let me write what is y. Y is nothing but y is equal to QA plus QB into x. Okay, so if the x value is 0, QA QB plus x. Okay, if x value is 0, the output is 0, right? So next x value is 1. So what is the value of this is addition, right? 0 plus 0 is 0 1 1 1, right? Okay, so next I need to find the value of QA plus. So QA plus is equal to, they are given QA into QA QB into x. So that is also the same value. So if x is 0 means QA plus is 0, right? And what is for this one. If x is 1, so I need to add this one. So if I add this one, I will get 0 1 1 1. Okay. So next, what is the value of qb? qb plus is equal to qa bar x. qa bar x. So if x value is 0, this qb plus is 0. If x value is 1, the inverse of this value, okay, inverse of this value is 1 1 0 0. Okay. So I'm going to assign the state values. So I'm going to assign a is equal to 0 0 and b is equal to 0 1 and c is equal to 1 0 and d is equal to 1 1 for this value. Okay. So if I assign, so this is my this becomes my state table, and this is a b c and d. So this value is under a, right, because I have assigned and what is this? This is b c, so b d c c, b d c c. Okay, so now I am going to draw the state diagram, third point. So I have determined the state table. Next one is state diagram. So how to draw the state diagram? So I have to draw the circle first. So this is A, and you have 4 state, right? So before that one, you have to see whether you can able to reduce the state table or not. So you can see I can able to reduce the state table, because if you see both the values are same. Okay, so I can reduce the state table, right? So before this one, so state table reduction. So for that one, let me copy this and paste it here. So since these two are same, I am going to replace D as C. Okay, so I am going to cut this one. Okay, I am going to replace D as C. So after that, so you can see these two are same, right? So I am going to replace this C as B. Okay, so again I am going to replace this one and C as B. Okay, now you can see though the next state are same, the output is different, so you have only 2 states. Okay, so next let me go for the state table. Only I am having 2 state, one is A and B. So if x is 0, if the present state is 0, if present state is 0, if x is 0, A is a present state. When x is 0, it goes to A. Okay, and if it is 1, it goes to B. If it is 1, it goes to B. What are the outputs for x is equal to 0? 0 and 0. So I am going to write the output at here. Okay, this is the value of x and this is the value of y. Okay, since it is a Mealy machine, Mealy state machine. So So next, when present state is B, x is equal to 0, it goes to A, and x is equal to 1, it goes to B. Okay, so x is equal to 1, it goes to B. When x is equal to 0, it goes to A. So when x is equal to 0, the output is 0. X is equal to 1, it is 1. So it is 0 and 1.